Hey, all right, so the beginning of this lesson actually is going to start with review of a lot of things that we've done quite a while ago. One of those things being expression versus equation. So remember that expression is something like x plus 3 or 2x minus 6, something like that. Equation, remember that this EQUA part is equal, so x plus 3 and then we have equals 7. So that's the difference between expression and equation. Zeros of a function, remember that zeros was just another way of saying x-intercepts. And remember that x-intercept is wherever the graph crosses the x-axis. And we get that by plugging in 0 for y. And remember that y is also f of x or, something like that. Solving equations, just remember how to do that, and then taking square roots of numbers. Remember that if we take a square root of a number, let's say the number 4, while that is the number 2, we can also square -2 and get that answer as well. Please, 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 please keep in mind that this thing right here is the square root. Okay, that's really important because to square a number, this means multiply by itself, where this means what will give you that number. So this is not a square root, okay? All right, now this part's really important, positive and negative numbers. Ready? All right, so this whole section is actually about solving quadratic equations, but we're only solving them when there is no b term. Remember the standard form was ax squared plus bx plus c? Well, in this whole section, our entire b term, this middle term, is not there anymore. Okay, so we don't have it. So remember the quadratic function. Quadratic functions are things like, oops, I didn't draw that long enough, things like that. So 3x squared plus 2x minus 1, or something of that nature. Now again, we'll only be dealing with something like 4x squared plus 2, functions like that. So if that's a quadratic function, then what would make it a quadratic equation? Well, making an equation would have something like 4x squared plus 2 equals 7, or something along those lines. Okay, so we add in that equal sign. That's the equation portion of it. All right, standard form, you remember that. I just went over it, but again, ax squared plus bx plus c. You probably have this written down several times already. You don't need to do it again. 0 of an equation, remember that 0 is the same as x-intercept. Okay, now we have this term right here, root of an equation. This is exactly the same as 0, so same as 0. Okay, so they mean exactly the same thing, so don't get confused if you see something asking for a root or something asking for a 0 or asking for an x-intercept. All three of those terms are completely interchangeable. Okay, so let's do a quick little review here, solving equations. Remember doing this way back in the beginning of the year when we first started. You start with adding 4 to both sides, so you get 2x equals 18, and then you divide by 2 to get x equals 9. Ta-da! And this over here, remember everything must balance. Okay, what you do to one side, you must do to the other side. So now what's the only difference when we're applying these steps to quadratic equations? We're going to solve it exactly the same way. So start with adding 4 to both sides. So you end up with 2x squared equals 18. And then divide by 2, just like we did last time, so we get x squared equals 9. Now I'm going to jump back real quick. Look at so far, we added 4 as our first step, divided by 2 as our second step, got the answer 9. We're doing the exact same steps, adding 4, dividing by 2. We do not take the square root until the last step. Okay, so don't do that until your very last step. So when you have this x squared equals 9, now we're going to take the square root of that Now remember back in the beginning we were doing that review, it's a positive 3 and a negative 3. So we put that plus or minus 3. So our two solutions are x equals 3 and x equals negative 3. Okay, both of these are solutions to this quadratic equation. Okay, so what we're going to do now with these is we're actually going to graph these equations. So think back to when we did axis symmetry and vertex. Remember, vertex was either where it went down and started coming back up, so it was either a minimum, or, so this is our vertex, or we had a maximum. So it was up here where it was coming up and starting to come back down again. But very important, this is with no b term, okay? These rules right here that I'm giving you only apply when there is no b term. It's very different when there are all three. So the axis of symmetry, when there is no b, is always x equals 0, which is essentially just the y-axis. So it means wherever you have your axis, so y and x, symmetry, remember it's the same on both sides, so the vertex is actually always going to fall on the y-axis, so we'll always look something like that, okay? The vertex, x-coordinate is the same as the axis of symmetry. This is always true right here. This is always a true statement regardless of there being 2 or 3 terms. But we know that for these specific examples, the x-coordinate for your vertex will always be 0. Now your y-coordinate is always your c term. So if we came back to an example that I wrote, let's see, right here, this right here is our c term. So it's whichever term that does not have a variable with it. So it'll be whatever your c term is. So I just put c here to show you it's the c term. Okay? So let's go ahead and do this. So first thing, we have to know what our axis of symmetry is and what our vertex is, and then I will show you where to go from there, okay? So if we wanted to graph this, here's something we need to know. Well, one thing that we have to know is axis of symmetry. Alright, there are only 2 terms. There's no b term. So x equals 0 will be our axis of symmetry. So this y-axis, I'm going to go ahead and draw it in just so you can see it well. Let me put this in, maybe in blue. This right here will be your axis of symmetry. It's not exactly straight, is it? My bad. Let me fix that. Okay, so there's your axis of symmetry, always. Alright? Now we need our vertex. So remember your vertex is this number here, so it'll always be 0, and then whatever your c term is, which in this case is -4. So there is our vertex. So we're going to go ahead and put that coordinate point, 0, -4, so 1, 2, 3, 4. There's our vertex. Okay, now what we have to know is kind of how it's increasing from here. In the last couple of sections we would do t-charts, you know, the x and y charts, and plug one number in and do all that other stuff. Well, remember we found zeros back here, or when we talked about finding zeros? Well, we can put in 0 for y, or our f of x, and then find out where it crosses the x-axis. So if we do that, we can find out where it crosses on the left, where it crosses on the right, and then that's all we need. We've got enough points that we can just connect it and make our parabola. So we're putting in 0, so now that we found our axis of symmetry and our vertex, I'm only going to erase this to give me some more room. Don't take this off your paper, okay? Okay. Now we need our zeros. Okay, so we're taking our f of x, and now it's becoming 0. Okay, so it's becoming 0. So 0 equals 3x squared minus 4. And now we solve it like a regular equation. Add 4 to both sides. So now we have 4 equals 3x squared. Alright, and then we divide by 3. So what we have here is 4 over 3 equals x squared. And how do we get rid of our square term? Do the opposite, take the square root. So I'm going to use that symmetric property and flip it, and we get x equals plus or minus the square root of 4 over 3. Okay, now you're looking at this and thinking, what in the world? We can't do that. And you're absolutely right. It's not really possible. But let's think of this. 4/3 is a little bit more than 1, right? So something like over here. But if we're taking the square root of that, oh, excuse me, if we're taking the square root of it, we're going to end up probably a little bit closer to our 0. So we're going to go ahead and put a point. We're just going to estimate. Okay, now you'll have a calculator so you'll be able to get the exact number, but still it's just an estimation is all you have to do. And then you go ahead and connect it on both sides. And there's your parabola, and there is your graph. All right, so axis of symmetry, vertex, zeros. Okay, now what if this happens? Okay, now let's see what's going to go on here. Axis of symmetry. Well, 2 terms, so x equals 0. We know that. So there's your axis of symmetry. And then we have, I'm going to put this again right here. All right, so there's our axis of symmetry. And then we need our vertex. We know that our x-coordinate is always going to be 0, and then our y-coordinate is going to be our c term, which is -4. So 0, -4. That's pretty coincidental that it ended up that way. All right, so 0, -4. Okay, so now the reason I have this, but what if we put 0 in here? So we're finding, remember this part right here is finding the zeros or roots or x-intercept. Remember those are all 3 interchangeable. -2x squared minus 4. So solve your equation by adding 4 to both sides. So we get 4 equals -2x squared. Divide by -2, divide by -2. Oops, that was weird. And you get -2 equals x squared. All right, now if you go to take the square root of this, you would have x equals the square root of -2. You can't do that. That is not possible. All right? So what does that mean if you get something like this? This means the parabola will never touch the x-axis. All right, so if we look back over here, well, we know that this negative means that the parabola is going to open downward, and if the vertex is here, then it's going to open down this way. Okay, so once we know that it's not going to touch the x-axis, we actually have to put in some values to find out what exactly would happen. So now we're going to come back and do that t-chart like we would, because we can't find any zeros. So let's go ahead and just put in the number 1. And remember, because it's symmetrical, we're just going to repeat it on both sides of our vertex. So if we put in 1 for x, we would get out -2 times 1 squared minus 4, which would give you -2 times 1 minus 4, which would give you -2 minus 4, which would give you -6. So 1, -6 would be a coordinate point. So right here, and it is symmetrical. See how this is exactly 1 spot away from the vertex, or from the axis of symmetry? It will be the same over here. So there would be your graph. Oh, that did not connect at all. My bad. Well, you know it's supposed to, so just make it work on your paper. Alright, so every time the x squared has a negative coefficient, it won't have any zeros, right? No. No, absolutely not. Negative coefficient only means that it opens downward. But if you look at this one, where is your vertex going to be? It's going to be at 0, 4, which means on your axis it's going to be here, but because it's negative, it's opening downward. So it will have zeros. Alright, so this is just review. Make sure you write these steps down. You start with finding the zeros, plug it in. Plug in 0 for y, find the axis of symmetry, find your vertex, and use all of those. And now it is time for a little celebration.
They call me Cuba Pete. I'm the king of the rumba beat. When I play the maracas, I go chick chicky boom.